In this video, we will look at producing an electrical schematic for our mechatronic system. We will not have time to build our robots in this module, unfortunately, and so demonstrations will be limited to Webots and Tinkercad simulations. However, there is optional practical work available during class, and you always have the option to build your own robot in Makerspace, if you wish. For any mechatronic design, you will need an engineering drawing of the mechanical aspects of the system, an electrical schematic showing all the required electronic components and wiring, and the full microcontroller program code. This provides all the necessary information either for yourself to build it, or for someone else to build your system, which would be the case if it was being mass-produced. We have already looked at producing engineering drawings, programming our robot, and designing our circuits. In this video, we will look at what we need in terms of an electrical schematic. The electrical schematic will mainly consist of all the electronic components of your system and how these connect together. It will also need to include all the power and ground connections and any data lines required. Your electrical schematic needs to include all the information needed to describe every detail of the electrical aspects of your system. Your schematic should be well structured. By this I mean laid out so it is easy to see where all the connections are going. It should be easy to read all the information on it. You may wish to color code your diagram to allow for easier visualization of the circuit. Pin numbers must be shown for every connection made, but does not have to include every pin on a component if those pins are not being used. For example, if you use an Arduino and are using digital pins 4 and 7, your schematic should show an Arduino component with pins 4 and 7 appropriately connected up, but it does not need to include all of the other digital pins which are not being used. The electrical schematic does not need to be an exact replica of how your electronics are physically arranged. The components on this schematic should be positioned so as to best give the clearest and most readable format for understanding how components are connected together. There are lots of options in which you can produce an electrical schematic for your system. We have used Multisim and Tinkercad in this module, which we will discuss in a little more detail shortly. Eagle is a professional PCB layout software and is a popular choice in industry. Fritzing is a popular hobbyist version of representing circuit layouts. This was free, although I believe there is now a small charge for it. Schematics.com is a free online version of producing detailed schematics. And you always have the choice of just drawing the schematic for yourself, either on a paint program or using, for example, PowerPoint. This DIY option gives you flexibility in presenting your schematic in whatever way you want to, although it will be a lot more time-consuming. Multisim is actually a simulator rather than a schematic generator, but its layout does automatically provide a schematic of your circuit. The good points of this are that it shows all the pin numbering required, all the component values, and you can lay out the design as you wish. My two criticisms are that firstly, although it contains a lot of components, it does not contain hardware such as Arduino, so this would need to be drawn in by hand. The second point is that components are not always represented as they would be physically. For example, an op-amp is rectangular in shape with pin number going in an anti-clockwise direction. Tinkercad is also a circuit simulator, but has the option of presenting the circuit as a schematic. This has much clearer labeling than in Multisim, with the bonus of including an Arduino component. The drawback of Tinkercad is mainly its limited number of components available to use. There is also no option for manually rearranging the layout of the schematic. Schematics.com provides a very clear layout of how your circuit is arranged. You can see there is a supply voltage rail along the top of the figure, a ground rail along the bottom, and all components are conveniently arranged and labeled for easy viewing. I think this option, or similar software, certainly gives the most informative way of presenting an electrical schematic, although this free software can sometimes be problematic to run. For the learning outcomes associated with this module, Multisim and Tinkercad are the most convenient software to use, and I recommend using these for any work required in the module. However, for future use, you may find some of the alternatives beneficial. In the next video for today's session, we will look at how we can take our WebOps simulation into a virtual prototype running on Tinkercad.